All right, what up, everybody? Get myself in this stage. It's been so long, I forgot how to use the damn software. Hey, there I am. Hey, welcome up. Welcome for everyone coming in here. We got a big group tonight. We got 8 people. I think my mic is on there, so if you can't hear me, let me know. All right, we got William Evans. He's all over chat right now. 188,000 miles on your Forester. Good job, man. And what's keeping it alive? Drain and fills. There you go. Quick wrench. Always glad to see you, sir. CVT has had no problems. It does have a hitch, and it's giddy up, though, under extremely light throttle when cold. Hey, we'll talk about that a little bit. It'll take off fine, but drop down in lower gear. Once it's warmed up, it's good to go. Yep, that's me, baby. All right, so we're going to be getting off here in a few minutes. Going to give a couple more people to jump into the stream and see what's going on. So we're running a poll right now just to see how folks are thinking about that transmission. Let me bring it up here and see what's going on. Hey, a lot of you don't seem to be too angry with CVTs. That's really good. 70% say that they work. 20% of you just straight up hate them. And 10% says they wish they lasted longer. Well, we're going to go over some tips and tricks to make them last a lot longer and get them on the road. It's going to go against what the salesman said to you and what the manufacturer says to you about how you should service your transmission. And you can apply this to pretty much all CVTs. The death of CVTs is pretty much just running the fluid into the ground. The manufacturers like to advertise lifetime fluids for their vehicles because it helps the sale of a new car. That's honestly what it is. Someone shopping around for a car says, like, I want a car with as little maintenance as possible. So, what does the manufacturer say? Oh, well, this transmission fluid's good forever because it's super expensive. It's $25 a quart. And you go, oh, that's great. What they don't tell you is when the fluid goes out, the transmission goes out. And when you get a new transmission, then you get new fluid and you start all over again. So, to kind of paraphrase a conversation I had with somebody who was very upset when I was recommending to them a transmission fluid service at 60,000 miles. They were bringing up the lifetime fluid out of their little brochure that they had when they bought the vehicle. And I says, okay, well, do you know the powertrain of your vehicle? When is your powertrain up? She's like, well, it's 5 years, 60,000 miles, but I have 60,000 miles, so I'm out of powertrain. I says, well, then, okay, cool. So the manufacturer has deemed that they are no longer responsible for the hardware on your vehicle. And she's like, well, what if I bought an extended warranty? I says, oh, then everything's good up to 100,000 then. You see how that works? It's just a marketing scheme. That's all it is. So if you're driving a vehicle with a CVT in it and you don't have any kind of manufacturer warranty and you don't have any kind of extended warranty to protect your transmission or your differentials, I recommend switching everything up to 30,000 miles. And we're going to go over how you can do this in your driveway. It's not that hard. You might need to invest and a few tools to do it, but I feel confident that you can do it because if you're here, I trust you. And if you get lost, you can always hit me up an email. Go to my main channel page, click on the about. There's my email. Very, very happy to work with you and keep your Subarus on the road because that is the motivation of this channel is to keep your vehicle on the road, not just Subarus, but any vehicles. Hands on mechanical, 82,000 miles on his 2017 Forester. That's amazing. That's really good to hear. Uh, Midwest says, I would expect that CVTs with their metal belt would last longer than like the 4 EAT with clutches that wear down, but that doesn't seem to be the case. Yeah, that's a good topic to bring up, and we'll talk about the chain. And not all chains and all CVTs are made the same. Some are better than others because they use better tension steel, they have better linkage in them. And a lot of it comes down to driving habits. Some drivers out there are just really aggressive on the throttle all the time. And, that's a lot of stress on the chain. And you should adjust your service maintenance based on your driving habits. If you drive like a bat out of hell, taking your kids to school, well, then you got to maintain it better. Kind of falls on the saying of you drive it like a race car, maintain it like a race car. All right. You don't see race car drivers driving on the same brakes and rotors after track day. No, they get all new stuff. So I think we got a pretty full house. We're going to get to it. Let me load up my slides here and get it in presentation mode. Takes me just a second with StreamYard because StreamYard has a kind of a kooky way of bringing up slides, but I am all over. I practiced today. We're going to share a screen, going to share a window, and ta-da! How's that look? Pretty awesome. Yeah, Williams on top of it. Train fills every 30,000 miles. You're right. You can do a lot to save the life of your differentials by draining and filling. There's a lot of people out there who are just flooding the internet with talking about how they've been driving on the same differential fluid for decades and they don't do anything. And then once you start talking to them and you find out what they're driving, these guys are driving like F-250 Super Duties. I'm like, bro, your differential has like 10 quarts of fluid in it. These little Subaru grocery getters, man, they have like a quart of fluid. These things run hot. They burn up. You got to change the fluid. So here we go. Now, I am going to give you some fair warning on this. I've been cramming on this module for a month straight. I probably got 30 hours into this. I've read an atrocious amount of material on the service side, and I've explored some other people who have been teaching this, and I've been taking some cliff notes from them. I've been working on the organization, so you are all my pilot here. We're going to test my organizational skills and my ability to translate these slides and get it through to you. I really want to streamline this presentation so I can make it bulletproof and have it up here for you to reference and learn about. So, with that said, we shall begin. All right. So, I'm building this to be kind of like a learning program. So, of course, I have to put some course objectives up there for you. But we're going to be going over how the system works, theory of operation, fluids, service data, uh, bulletins that are out there, the two different types of transmissions that Subaru has manufactured over the years. Okay, we started out with a basic Gen 1 TR580, and then when Generation 2 came out, the TR580 got a bit of a mutation. It kept a lot of the same principles, but they just made it more compact. And they came out with a big, beefier version, the TR690. And if you pay attention, you'll learn something really clever about the TR690 that I like bragging about. HVAC, my man, you're here. It's my best subscriber right here. He's been with me since day one. All right, so we're going to go over some component locations and then pretty much just how all this fluid flows through the transmission. So if you are having some concerns with your transmission and you got your own scan tool and you can look at the data PIDs, all right, you can look at the live data, then maybe you can get an idea what's going on and maybe you can fix it yourself instead of going into the shop and spending hundreds of thousands of dollars because some of the repairs on these transmissions, they're very simple driveway jobs. And when I rate the repairs, I'm going to rate them in 12-ounce beers. Okay. All right. If you are doing these repairs and you need some service data at your disposal, hang on, William. Yes, we are going to hit the relearn procedure. Yes, sir, we will. And I'm going to go over some tools that you can get. There's a scan tool that you can get for $100 that'll do the transmission relearn. All right. So if you do need any kind of service data from Subaru, you can purchase your own temporary subscription. You can get a little 3-day access there for 35 bucks. That's really good. And you're not just going to get service data, you're going to get access to your owners. You can get a digital version of your owner's manual. You can see newsletters that actually get published to technicians and to the dealerships. You're going to get TSBs. So you're going to get everything that we get except for tech line. All right. That's one of the benefits that I get at a dealership is if I hit a brick wall with all the service information and I can't make heads or tails of something, then I can put together a case file and I can present it to the Subaru tech line and they can start giving me some help. All right, so we're gonna hit up some safeties here. When you start opening up these systems, even if you're doing a drain and fill, I want you to clean up that area around it. All right. It's extremely important to not let any outside contaminants get in there. Like you see all this dirt and this grease around there. If I was going to remove this transmission pan, and reseal it, I would clean up that entire area before I even open it up because you got wind, your tools drag dirt in. Maybe you're just trying to wipe down a surface to clean it up before you glue it back together. Well, that rag is going to drag in that surrounding trash. So keep it clean. If you do have access to a shop, there are some shops in cities where they have like a full service shop that you can rent a stall. Like here in my area in Texas, we have a couple of independent shops and you can rent out a two-post lift and you can do some pretty heavy line work there. I think the going rate is about $150 a day. Not bad. And if your car has to stay the night, then they'll charge you a lot fee of $50 a day. So if you're going to do a big job where you got to pull the transmission out, you want to do it yourself, but you don't want to do it in the driveway, hey, find one of these shops and they have the transmission jacks for you to use. Now, obviously, you want to have a fundamental understanding of how this shop equipment works. Don't take it for granted. It's the it's the simple things, guys, that we learn the hardest way. Even myself, I do a routine task again and again and again. I will forget some of the stupidest things, and those are the things that get you bit in the ass. I made a short about forgetting an oil change sticker after I rebuilt the lady's engine, and she freaked out. And with good reason too. She's used to seeing the oil change sticker. She doesn't care that I set the oil change on the instrument cluster. She wants her sticker. So she was very questionable from then on about all the other thousands of dollars of work that she paid for. And that's the last thing you want is somebody to question your work. So from that I learned to build a little post checklist whenever I'm done with the job. I keep it on my clipboard and I go, yep, yep, yep. Okay, good. Oh, wait, I forgot this. I better do this. Everything down from checking air pressure, checking lug nuts again, uh, oil change stickers. Even now, I have a can of multi-purpose cleaner and a microfiber. Clean the door handle off. Hey, I get in and out of the car. My elbows get dirty. My forearms get dirty. Make sure I didn't leave a stain on the armrest or the door. People don't like that stuff. And it's getting harder and harder and harder as these cars get nicer and nicer and nicer. All right. So if you go to one of these shops, be prepared that you might have to take a safety class. Um, the ones that are in my town, they actually mandate that you have to take a safety class before you can rent a stall. And that has to be scheduled. Like they only do safety classes on Mondays, and it's a 1 to 2 hour, depending on how many questions they get. But they go over how to use the transmission jack, how to use the lift and put the lift on the locks, how to ask questions if you need a special tool, shop air, first aid, everything. They don't want to get in a lawsuit. Okay. Same if you went to a gym. If you got a gym membership, they just don't let you walk in. No, they got to walk you around the gym. They got to show you where everything's at. And You sign a waiver in case you drop a weight on your toe. Removing some of this stuff out of the vehicle, this is not easy, especially if you're up there in the north. I know a lot. I got a lot of followers that are up in the rust belts. These transmissions don't like to separate from the engines too much, and when you finally get them, that's a big shift of weight off of the vehicle. So you might have to add some extra stabilizer posts. We call those floor jacks. They're the big 6 foot tall posts, and you want to, whoops, and you want to set that engine up to catch that weight on the lift. I will do that. I will put a uh, post jack on the rear bumper of the vehicle where the frame is at, just to help out with any kind of rocking. Because man, I've seen some cars rock once you take about a 1,100 pound transmission out of there. Scary, especially on trucks too. They got that big long extended bed. Scary stuff. Take breaks if you get frustrated, all right? I get frustrated, so I'll walk away, take a little bit, ask for some help. What's going on, Mr. Canadian Diesel? Hey, all you cool beans in that chat. Oh, yeah, man. We're all good here. All right, so you're working on this transmission. Not every hammer is the best hammer in the toolbox. When I work on these transmissions, this is like porcelain, all right? They are aluminum casings. It's cast aluminum. It's durable to a point. It's got some brittleness to it, and if you start hitting it with metal hammers, you can cause micro cracks. If you start using air hammers, you can cause micro cracks. So I've invested in some really nice dead blow hammers. All right. If you're not familiar with a company called Tekton, Tekton, I really do stand behind their hammers. They got beautiful hammers, and they're made by Estwing tools. So they're American hammers. You can get dead blows filled with split shots. You can get ball peens with split shots. And now they have solid face hammers. Great company there. I don't use chisels when I'm trying to separate the case portions. I'll actually use one of these big plastic chisels, the kind that are used to scrape wheel weights off. Those are super cheap. I can get 3 of them for 25 bucks. If they get dorked up a little bit, maybe I'll chew them up with a pocket knife, but when they're done, they're done. The last thing I want to do is try to pry this case apart and cause a dent in the mating surface. And that goes for the oil pan too. You got to be careful about that. I got a really cool tool I'm going to show you that I use for all oil pans, and I've never ever torn up an oil pan or scraped a mating surface ever since I bought one of them. This is just a quick little chart of all the fluids that Subaru has been using in their automatics and now into their CVTs. We have now about 5 different versions of CVT fluid. All right, we got CVT fluid Gen 1 that was now replaced by CVT fluid 2. So CVT fluid 2 replaced 1. That's why we don't see it on a chart anymore. We have a CVT high torque fluid. We have an LV fluid. And now we got some new crazy blue fluid coming out for the new 2022s and up. So you want to check your service data. You want to make sure you're putting the correct engineered fluid into your CVT transmission. It's not like the good old days where you could just put any kind of bulk ATF into your transmission and it was okay. The CVTs, they operate completely different. So don't take that chance. It's only going to cost you an extra couple bucks a quart. Use the appropriate tools. I'm just throwing up pictures, trying to fill up the slide with presentation here. You don't have to buy expensive Snap-on stuff. I know a lot of you like using Harbor Freight torque wrenches. I'm going to throw a bone up there for my Tekton tools. They got torque wrenches. So you can get a set of 3/8 torque wrenches, you know, guys, for like 40 bucks. Take care of them. They work. You got to torque this thing back together. You got to do it right. Even those drain pans. Those drain pans, I see a lot of them come back leaking because people just want to zip everything in and they go snug quarter turn, snug quarter turn. 7 foot-pounds. because when you crush that pan too much or you crush those mating surfaces too much, then the gasket maker doesn't do a good job. It doesn't make a good bead seal inside the case, and it'll just scissor it off and you lose your bead and it comes back with a leak. So look all that stuff up in your service data. Using the correct gasket maker is critical. Not one gasket maker does it all. I don't care what the auto part guy says. All right. Because he's not going to be the one who's going to be crawling under your car and fixing his mistake. So I'm just pointing out right here, we got this big 3 bond tube here, 1217B. It's a red color. That's what we use to reseal the pans. Then we use this other one, 1215. It's a low viscosity gasket maker, and it comes out looking like you got diarrhea. That's normal. But that's what we use to put the case halves together. And don't quote me on this one. I'm still learning about this one. I got an engineer trying to explain it to me, but I was too stupid. A lot of his information went over the head. But basically, this low viscosity stuff, if you go a little too overkill with it, it's designed to not clog anything up. Unlike using a traditional gasket maker, which is going to turn into a hard solid bead and then it's going to clog some passageways. So here we are. We're getting into the generation one. This generation one Subaru CVT came out in 2010. That's when the Outback got a completely redesign. It went from a wagon into like this 8-inch ride height crossover SUV thing that was trying to take on the Ford Explorer. Mrs. Williams says, don't confuse the driver's side fill plug, left side of the front diff fill. That yes, yes. Service data. Double check it. There's a lot of you'll see it later on, but there's a lot of plugs on the side of the transmission case. They all look the same, so you have to make sure the quadrant that you're in is correct. When we first transitioned over to CVTs, people were not reading the service data correctly. They would drain their differential. They thought they were filling their differential, but they were pumping differential fluid into their transmission, and then their front differential would lock up and die. Eventually, your your CVT would get very, very angry at the differential fluid that was mixed in there. So this is just kind of pointing out here. We started off on only two vehicles. The Legacy and the Outback got CVTs. Everything else was still sticking around with the Ford EAT. That was our automatic transmission. If you had a 6-cylinder running with the EZ36, you still had the 5 EAT. My favorite transmission, I like the 5 EAT. It's a beast. So here's some G Whiz information. If you've ever wanted to know why do we have the name TR580 and TR690, folks, it's just the difference between the two pulleys inside the transmission. That's it. So now you know. Here's a good picture of what our chain looks like. It's a multi-layered chain, lot of links. It's actually a really good chain. I've seen very few chains in the Subarus pop. The ones that they did, they were 100,000 mile CVTs. They had absolutely no service on them except engine oil changes. So that car was just screaming to have problems. I mean, like they didn't even do tune-ups. A lot of people don't know when they buy a vehicle, it needs maintenance. And unfortunately, a lot of people are getting the information put in their head from the internet that mechanics are evil, garages are evil, dealerships are called stealerships. I understand every once in a while someone's going to get taken advantage of because they were ignorant to something, but that's why I'm promoting this channel is I want to make you aware of services. If you think you're getting hoodwinked, let me know. All right, I'll tell you. All right, we have a redesigned torque converter that goes with this CVT. It locks up super early. All right. It on the automatic transmissions, it was very normal for this torque converter to start locking up maybe at about 20, 25 miles an hour. These things are locking up at almost 10 miles an hour. So as soon as you're out of the driveway, torque converter's locked up. It's giving you better power instantaneously. If you did take the torque converter off of the CVT transmission, there's going to be a little cover right here. This is that front chain pump cover. Now, we do have a bulletin, and we'll talk about it towards the end, but there's a bulletin that talks about these front chain pump covers leaking. I repair a lot of them, folks. And if you're not eligible for a free repair at a dealership, because we do have an extended warranty, all right? There's an extended warranty on all CVTs from 2010 to 2018 or 19. Pretty close to that. But it covers fluid leaks, it covers malfunctions, it covers wiring harnesses. So before you go to an independent shop, check in with your local dealership and see if you're eligible. And keep in mind that just because you drive a, what are we at? This is 2024. All right. So let's say you got a 2015. You're like, yes, I got a 2015 Subaru. It's got 98,000 miles. I'm eligible. That date starts from the date of manufacture. It doesn't start from the date of sale. All right. So if your 2015 was manufactured really early in the year, and maybe a little bit in the year before, because that does happen, we start pumping out the vehicles 6 months early, you might fall out of eligibility. But don't give up hope yet. Ask for help. Help can be provided if you're nice, if you say please, and if you still get turned away by an advisor, schedule time to talk with the service manager. Don't bombard them. All right. Don't be a dick and run in there and say, you owe me this. There's a bulletin. No, just schedule an appointment, chit chat them up, be nice. You'd be surprised how much they want to offer an olive branch to you. They have resources to help you, but they also have the decision not to help you if you're an angry person. Don't waste their time. So what's controlling the all-wheel drive action? There's no gears. It's just a multi-plate clutch pack. We'll have a special section where we talk about that. I'm just pointing out that it's 5 clutches. Should it be more? Kind of, yeah. And we have a gear ratio range between the two pulleys of 3.5 to half, and we have a fixed ratio in reverse. Now the shifter, why am I showing you a slide about the shifter? Well, there's some interesting things about the shifter that you might want to know. All right. So, some obvious things right here is you can start the vehicle in park and neutral. All right. And as a safety, if you turn the engine off and you're in drive or reverse, that's like being in neutral. The car could potentially roll away. So check the area where you're in at. We had a few people who were like, "Whoops, my car rolled into the garage door." The CVTs did come out with some manual mode. So you got it in D, you slap the shifter over, you got 6 choices of fixed gear ratios to go in the manual. And we put some sporty little shifters right here on the steering wheel where if you're not in manual mode, you can still temporarily gear down if you want to like pull out in front of somebody. I'm sorry, if you want to like pass somebody on the highway, you wanted to set your transmission up to go into a lower gear so you could pull ahead. We gave you that. So you can drive, you're in drive normally, and then you hit the down, the one on the left to go down a gear, and you'll feel it kind of sink in, and you can go. And once you get to a stable driving speed, the transmission computers could automatically take over and put you in a variable ratio again. So you don't have to always reach down for the shifter. You can start playing with those paddle shifters right away. Another really cool feature that transferred over from the automatic transmissions, the 4 EAT and the 5 EAT, Let's say you're trying to take off on a slippier surface. I know the Subarus brag about having all-wheel drive, but they still wipe out. All right, and if you're trying to take off on some slippery surface, snow and ice, then you can put it in manual and you can upshift into two, and it'll actually hold a high gear, and it won't be so torquey, and you'll be able to kind of crawl out of the position that you're in. That works good for mud and snow and ice. It's a really, really good way to take off without spinning out. It's so if you guys up north, try that out. It's pretty cool. I know we kind of passed winter over, so you'll have to write yourself a little note in the glove box to try it out when you get on some slippery surfaces. All right, we already covered fluids. Your transmission, your Gen 1 holds 12 quarts, and that uh the amount of fluid that these transmissions hold through the different generations, it's still pretty the same, 12 to 13 quarts. And we'll go over the filling procedure in that. The generation 1 actually just ran the cooling system through the radiator, just like an old school automatic. Later on, we came out with uh, a separate style cooling system. Come on, monkey. How am I going to present this material, man? I need a PowerPoint to keep me on track. This ain't JT. I'm not going to go all sideways and on a tangent. I'm really good at getting on tangents. You almost got me on a tangent. Stop that. All right. This is the secret weapon of the all wheel drive. This is nickname your center differential. All it is, it's just a slipping clutch pack. We're going to go over the all-wheel drive circuit of the transmission and how pressure is applied to make these things glue up and then send power to the rear. Now, through all-wheel drive system on your Imprezas, your Legacies, and your Outbacks, they all have a front biased split. Okay, they're like 60% biased to the front, and they can shift just like maybe 5% of the front power to the rear. We give you front wheel drive just for control. Front wheel drive, if you've everybody's driven front wheel drive and gone through a corner, you know that front wheel drive likes to pull you out of the corner. Even though rear wheel drive was a lot of fun to drive through a corner, front wheel drive just offers you a little bit more control. Now we're utilizing the ability of rear wheels at the same time to help push you into a corner and pull you out of a corner and stabilize you through a corner. And here's a sideways look at your generation 1. It's divided up into 4 pieces. All right. In the red, we have the extension case. In the yellow, we have the intermediate case. Then you have your main transmission case in blue. And then this is your converter case all the way up front. Pay attention to the amount of segments that are on this Gen 1, because as we get into Gen 2, one of those segments is going to disappear. So if you have a vehicle and you're shopping around for a used transmission because your other one broke, or maybe you tried to flip a car and you're hunting around, sometimes the people selling them don't know what they have. So if you have a 2010 to 2014 uh, Outback and you're shopping for a used transmission and you see the side of it and you go, wait, there's 3 segments. Joe taught me the Gen 1 has 4 segments. That guy doesn't know what he's selling. I'm going to walk away. Right, this is your fill plug. We're on the tail housing, all right? That's right back here in the red. All right, this is where you're going to fill your transmission up. Obviously, the black pan down here has a drain plug. I truly wish CVTs would last 100,000 miles. I can understand the problem with heavy foot driving killing them, but even with granny driving people, they just don't last like conventional planetary systems. Hey, man, you're absolutely right. I'm not going to fight you on that one. Not going to fight you on that one. But manufacturers, they're still trying hard to make these things work. And the new ones that have come out, I've been really astonished at how well that they're doing. Except for a few exceptions that they told people they could do some things with the transmission, made me skeptical. But only time will tell. All right. So, guys, this is a 8 millimeter hex, And if you take this off for the first time, it's going to be a son of a gun. I'm just going to warn you. But don't use your cordless tools and try and break it off. Right? The vibrations from the impact. I've seen people put micro cracks back here on the threads. Again, it's an aluminum cast. It's brittle. It doesn't like those vibrations. So you're just going to have to man up, get a pipe on your wrench, and break it off. And when it pops off, you're going to feel like you broke it. Another big important tip is take a good look and see how deep that hex key needs to go in there. All right. A really common rookie mistake is you got your socket with your 8 millimeter hex, and you're like, hey, I'm in, but you're only in maybe about like 2 or 3 millimeters. That sucker needs to go in about 8 millimeters. They get crudted up with dirt, you get corrosion on there. So you might have to wash it out with some brake parts cleaner. And then with some light tapping of the back of your wrench, you can knock it in. I do this service so much that I actually have a socket and I've actually put a tick mark all around the ring of it so I know that it's seated in correctly because it was really, really easy to round these suckers out. And speaking of rounding out, you want to stay away from those hex keys to have the little ball on the end. This The balls on the end of those hex keys, that's good after you break the initial torque. That's so you can be at a weird angle and thread it out, or maybe just kind of walk it in and then go in and torque it down. All right. My favorite cheap 8 millimeter hex is actually from Harbor Freight. They make a sweet half-inch version. It's impact grade, but I don't impact. I just like the style of the impact one. All right. Now, if you're doing a drain and fill, you can do this at home, but you got to make sure you're set up correctly. If your driveway has a slope, you're going to get a bad level reading when you fill it up. So you want to be on a flat surface. I'm not joking here. Flat surface. As good as you can get it. You'll drain it from the pan, measure the amount of fluid that you collect, and start putting that same amount of fluid back into this fill plug. Now, you may not get the same amount of fluid put back in initially. That's okay. You're just going to temporarily close it up, turn the car on for a few seconds, and then add more. And then you can turn the car on, leave it on. You can shift through the gears, let it warm up to about 100 degrees Fahrenheit, and then top it off while it's running, just like old school automatics. Okay. You got to check fluid level while the pump is moving. It's a very common mistake for people to fill these things up when the transmissions are cold and they're off. Then they start driving down the road and they hear the oil pump starving. And by then, damage is done. You don't want to do that. But this is a really safe procedure that you can do at home. I emphasize changing this fluid out every 30,000 miles. Now, how much fluid are you going to collect on a drain and fill? About 75%. And it's okay to leave that other 25% in. You'll just recycle it out at 60,000 miles. And William's got something over here. My 17 takes 15 minutes at highway speed to reach 170. That's about normal, yeah. I've heard 170 is the warm up temp before you want to goose it. Pretty much. That's when the TCM is going to give you some more power. See, the TCM is programmed to not let you break the transmission. And we'll cover cold startup strategies of the TCM here. But you're right. Just like the engines have the same warm up strategy, they retard the timing on the engine. The engine doesn't feel as peppy, and that's because the timing's retarded. So that way it's warming up the catalytic. It wants to get the coolant warm, it wants to get the oil warm. And then once everything's warmed up, it's like, go. So same strategy here with the transmission. And the transmission actually has a pretty cool strategy to help expedite that warm up too. And on the generation 2s and the new models that are coming out, I don't even think we're calling them Gen 3s yet. They're still kind of Gen 2 modified. But we're putting even more fast warm up strategy into that fluid because we understand that the best way to get these things operational and make the customers happy is to get them hot fast. So here's some overview of our drain plugs here, especially for our differential. Pay attention here. So this first picture up top, we got a plug with a hose coming out of it. This is unique to the Gen 1 and the TR690. Okay. The TR690 carried this fill plug design all the way up to the current date. It's still there. The Gen 1s, the TR580s, started out with this. So that's where you'll fill your fluid up at. And note that you don't have a dipstick. So how do we check the fluid level when you're filling it up? Well, look underneath. You got this big frickin' socket right here, the T70. All right. And right beside it, you got a 14 millimeter bolt. What you're going to do is you're going to drain your fluid out of the T70 spot. Once it's all drained out, you'll tighten it up. It goes to about 50 foot-pounds if you're using the carbon crush washer. Okay. There's two crush washers that are out there on the market. There's the OEM one, which is like a carbon composite, and it torques really tight, 50 foot-pounds. It's going to feel like you're breaking it. Then there's the aftermarket one, which is copper, and that's like 30 foot-pounds. I don't like the copper ones. They leak. I like the I like the carbon ones, and they're cheap. They're only a couple of bucks. Can you reuse the old one? I've seen people do it and get away with it, but this is a channel where I'm going to tell you to use best practices. Okay, so you put that diff plug back. Then you open this 14 millimeter plug up and you start filling up with fluid. This only holds about a quart and a half of fluid. And inside of that differential, there's a little pipe that goes up. And when you hit that level, it flows over and it goes down the pipe and it'll start drizzling out that check valve. That's how you know you topped off your transmission. If it's streaming out really heavy, wait till it starts steadily streaming out. And when it's a slow drip, you don't have to wait for it to go drip, drip, drip. No, no. If it's just like a little stream, like a leaky faucet, go ahead and plug it up. You're done. Okay. And then make sure you put this fill plug back. I see a lot of DIYers screw this up because they forget to put that fill plug back and moisture gets in the front differential and ruins the fluid. Also, when you pull that plug out, note that it has a breather hose. While you're in there, check that breather hose, make sure it's not clogged. Okay. If you have a clogged breather hose, it's not going to allow the front differential to vent correctly, and it's eventually going to put that pressure somewhere else, which is going to be your gasket maker. And you're going to start getting a differential leak coming out of your axle seals and maybe your case half. You don't want that. So if you're in there, check that hose, make sure it's not clogged. Up north, it's really common for dirt and spiders and other kind of bugs to kind of just build webs in there, especially if you get a barn find. I'm making another note right here. Do not impact these plugs. I understand that they can be seized and stuck. Heat is your best friend. Just get a torch, warm it up. Get a cheater pipe. You'll be okay. Here's a better outline of what we're looking at if those pictures didn't get make it stand out too much. They are valve body replacements. Let me check chat. Chat kind of blew up here in a sec. Okay, William. Top off and park. Yes, we're talking about CVT fluid here. All right, not differential. So CVT fluid. Yes, you will do an initial fill until it spills out of the plug and park. Then you'll put your plug back. You can start your car for a few seconds. That gets the torque converter turning, gets the oil pump turning, and it charges up all the lines. Shut it down. Go back. Do another top off. if it needs it. If it didn't need it, all right, hooray. Start the car, let the fluid get warm. If you start hearing like a an oil pump kind of starvation noise, don't worry. Go ahead, leave the car on and keep filling up fluid until it spills out. If your fluid has any kind of champagne bubbles in it, like that's normal. It can happen. All you got to do is just uh, turn the car off, take a 30-minute break, come back and try again. Aeration sometimes does happen if you got an air pocket in the system. Though the transmission does have contingencies to prevent that, contingencies are not 100%. Yeah, so you got to top it off and drive? So you do cycle the shifter, monkey. After you do your second fill check and nothing, and it doesn't need any more at that time, then you can shift through all the gears to get the fluid going through the pressure lines, and then you can check it again. Yeah, after cycling through the gears and at 100 degrees, that 100 degrees is the sweet spot for checking your fluid level because the fluid level does change with temperature. So if the temperature got too high, let's say if you're in the 130s now, it's going to read higher. So that's why we have a sweet spot, and you'll need a scan tool to monitor that. There's no transmission temperature gauge on the gauge cluster for you to monitor. Right, keep talking in chat. Let me know if that was the right thing. Oops. Way to go. Waste my time, Will. Waste my time, monkey. All right. So, hey, folks, the valve body lives on the bottom of the transmission. When we get to the Generation 2s, we're going to talk about where they got relocated and why they got relocated. But on these Generation 1s, they're in the pan. So, you're going to lose fluid, of course. I do not recommend recycling that fluid. Put new fluid in. To remove this, note the different colors of bolts, okay? That's kind of a good clue of which ones are going to come out. Reference your service data and make sure you pull them all out correctly. You do have a harness clip right here. You will have to disconnect. It's not a booger to disconnect, but you should take precaution. Avoid using pliers and screwdrivers. It wants to come out nicely. When you go to reseal your oil pan, use the 1217B. That's the stuff that we recommend or equivalent. And note the torque rating on the pan, 5 Newton meters. That's a really, really low torque. It's low for a reason. Because, like I said, if this is the transmission case and this is the pan, you squeeze them together, eventually you're going to squeeze all your gasket maker out and you're not going to have a good seal. So that's why it has such a low torque. Same thing for putting the bolts back in the valve body, 9 Newton meters. All right. Get them all started by hand and then just kind of go in an inside counterclockwise fashion, torque them all down correctly. Those bolts are going into aluminum. I've seen people try and just use their zippy guns thinking they got like the torque right here in their finger. And next thing you know, that bolt strips out. Doesn't take much. When we do drop this out, note up here in this top picture right here where the arrow's pointing, okay, there's a little pipe there. That pipe has to transfer from the old valve body to the new valve body, and there's O-rings that you got to get to go with it. When you ask the parts store or you ask the dealership for a valve body, this thing's so old, they might forget to recommend these to you. So I'm telling you now, tell them that you need the O-rings that go to the pipe. And there's two of them. All right. There's two of them on that pipe. In the beginning, there was a lot of comebacks on these transmissions and a lot of vehicles that stayed at the dealership for a very long time because people were not reading service data. They were putting new valve bodies in these things and they weren't moving the pipe over and they couldn't figure out why the car didn't want to move. A lot of mistakes were made by just not reading your service data. Global Jesus, how about 2017 WRX 6 speed? The manual? We're going to do a manual class pretty soon. I got to really nail down this CVT class first. This is the most popular, and then we're going to be putting together a 5 speed class, and we're going to put together a 6 speed class. We're going to talk about tearing down the transmissions. One of the big setbacks of why I didn't get into that one first is because I don't have a donor. So if I can get a some donated transmissions, so that way I can take some better videos and pictures of actually tearing the thing down and putting it back together, uh, then yeah, I'll jump right on it, man. No Loctite. You don't need it. Don't use it. No Loctite. They stay in there pretty good. This is my secret weapon, guys. This is made by JTC. 1350 is the part number. This is my favorite oil pan remover tool. I want to point out right here where I zoomed in. This anvil side, it's got a chamfer, a really nice chamfer. All right. That is what you're going to hit on after you sink that blade in. That's a double beveled blade. So it's not going to dig into the pan. It's not going to dig into the mating surface on the transmission case. You're going to tap it in, as I'll show in a video. You'll tap it in, and then you can knock it down the pan length. It's a beautiful tool. It's got a little removable hammer too. It gets in all the tight places. I love this thing, and I think I've done like maybe 300 pans before I finally wore it out. So if you're a home gamer, you ain't gonna wear that thing out. Your torque converter, if you're gonna take the transmission out by yourself, you do want to make some sort of apparatus to hold that torque converter in place. That torque converter wants to stay with the engine if you're pulling it out at a bad angle. If you weren't there for the live stream where I showed you guys how to pull out a transmission, here's the summary. This is right here. My hand is representing the back face of the engine. This is the front face of the transmission bell housing. This is how they are together. They want to come apart perpendicularly, okay? They don't want to be at an angle, okay? They don't want to be like this. So when you're pulling that transmission out, it doesn't want to come straight back out cleanly because you're going to smack into the unibody of the vehicle, okay? That's the chassis. You're going to smack into the chassis. So you have to dip the transmission down about 5-7 degrees, which means that you're going to have to get something to push up on the engine. Using this is Subaru's version of a special tool, but as you can see, it's just bent metal, guys. All right, you could probably make this with a Bud Light can, as some guy has done right here with a piece of scrap metal. All right, do what you got to do to just keep it from wanting to fall out. Right here, the Subaru special tool is $300. Why? Because it's a damn one-off tool. This guy just had a piece of scrap metal and he just kind of hammered it up and it works. It's great. All right, so putting your transmission back in, obviously the torque converter has to be in the transmission, right? But you got to make sure that it's seated all the way. Go back and watch my live stream of pulling out a transmission, and I show you how to put in the torque converter correctly. It can be a son of a gun. All right. If it's your first time, it's going to ruin your life until you kind of learn the tips and tricks of how to sync it. It wants to go in nicely. You don't have to force it, but the tolerances are super, super tight. So if your torque converter is nose down, maybe 1 degree, it's not going to want to go in nice. So you're going to have to kind of lift up on it and find that sweet spot and spin it to make it go in. There's 3 catches on it. Go back and watch the live stream of how I put that torque converter in. If you don't put it in correctly and it is still sticking out too much, you will smash that torque converter through your oil pump case and it's game over. On these generation ones, if you mess up your oil pump, it's transmission teardown. All right. Now we fixed that problem on the Gen 2s. We gave you um, a service port to get to the oil pump separately right behind the torque converter. But we hope that you learned your lesson. I'm using a tiny hammer because I'm in a tight space. In other spaces, I can use a bigger hammer. I've used as big as a 3-pound hammer on it. It's a good tool. Didn't hurt anything, guys. No screwdrivers, no chisels necessary. Just a little patience and the right tool. Here's something you may not know. We did a stupid thing on this generation Outback. There's no bottom engine mounts connected to the engine. So we put the engine mounts on the transmission. So if you take the transmission out, there's going to be nothing holding up your engine except a couple of radiator hoses. Thanks, Monkey. It's like I'm doing it for you guys because you have so many questions and you guys want to do this yourself. So here's everything. So if you're going to pull this transmission out, you're going to need something to hold the engine up. Now, there's two tools on the market that I stand behind. All right. The first one's this Norco 78099. It's probably the best one out there because it works really good for some of these engine bays that have the squirrely flashing all the way around, and you can MacGyver this thing up however you want. Okay. Then you have the super cheap one by OTC. It's just some pipe and it goes on the strut mounts. And then you got this third point. This is called a traversing engine stay tool. All right. Because it's got 3 points of contact. I'll explain why that's important. And then this just lays right up here on the front part of the metal right above the radiator core support. Be very careful with this OTC one. I've seen a lot of people put it in the wrong place and then they crush the radiator. So be aware of what you're doing. Norco one for the win, but it's 3 times as much. This OTC one, I found mine used on back then we had Craigslist. Yeah, I found it on Craigslist for 150 bucks, but it sells new shipped on Amazon for like 250. It's a great tool. It works. Just know how to use it correctly. Now, if you go to the Horrible Freight and you're like, "Hey man, they have one for $50, Joe." Well, yeah, they have one that goes across strut mount to strut mount, and that's it. It doesn't have a center post. That center post is there to keep the damn thing from falling forward. I have seen that thing, that two post one. I've seen that two post one from Harbor Freight fall forward and the engine went. That was a bad day for that dude. That was a really bad day. Now, he was very, very lucky the engine survived. The engine did not fall a four the engine did not fall 6 feet onto the ground. It was right as he was starting to lift the vehicle with the lift. Okay. He was only maybe 6 inches off the ground and the thing just went boom. So he had to get a new oil pan. But his pride was definitely hurt. Ruined the radiator hoses, broke some AC lines. It was a mess, guys. Get the right tool for the right job. Now, can you get the cheap $50 one and jerry rig something with some 2 by 4s? Probably, yeah. Probably, but I'm not a carpenter. I'm not good at building things. I'm good at taking things apart. And I'm also really, really good at organizing the parts left over from things that I put together. So I'm going to emphasize something right here. This is a picture of me doing one. Now, if you're reading the shop manual on how to do this transmission removal, it's going to tell you to use a special tool to go in replacement of the front engine mount. Okay, we call that the rhino horn. And it's a pre set up jig that tilts the engine up at the sweet spot angle. That thing's expensive, takes time to set up. I don't have time for that because I'm flag and I'm encouraged to get things done fast. So I got my wood block and I got my stripper pole set right there. And I'm just pushing up on the bottom of the engine. Nice and safe. Now, do we push up on the oil pan, guys, or do we push up on the exhaust manifold? I'm going to tell you don't push on the oil pans, all right? Because that pickup tube is about that far away, okay? About 8 millimeters away from that oil pan. And if you put a dent in that oil pan, you'll clog that pickup tube or you'll oil starve that pickup tube because now the pan, instead of being flat, it has a divot up like this. All right. It has an upward peak and the oil can't get around it. It's always falling down. So it can't get siphoned up through the oil pickup tube. I actually have a 4x4 going across the entire exhaust manifold. So when I'm pushing on the exhaust, I'm not piercing one point with all the weight of the engine. It's spread out very evenly. So I thought this out when I created this cheat. It's very important. A lot of people make the mistake. They just put these floor jacks, these stripper poles on one spot, and then they crack the exhaust. There's a flex pipe in this exhaust, and you'll crack the welds in the flex pipe. So get a board, put it all the way across. I don't trust 2x4s. I just went to the Home Depot. They got scrap lumber everywhere at like 25 cents a foot. I got a 4x4. It's my best friend. Okay, the lift that you need to get out of this engine is about 5 to 10 degrees max. That's it. The transmission then dips down equally. If you screw this up, then right here on the front of on the torque converter, you're going to break that snout. And you might think like, well, we don't really need a nose, right? That torque converter doesn't need a nose. Actually, it does. It has a purpose. Even though you have 4 bolts that go to the back flex plate of the engine, the torque converter adapter plate, as some manufacturers call it, I've heard it called flex plate, torque converter adapter plate. Those 4 bolts are not enough. You still need that pilot to stabilize the harmonics that are created by this thing spinning at like 6,000 RPM. So if you did a transmission R&R on a Subaru and you fire it up and you're like, man, like this thing's got a vibration, that snout might be broken. Here is where I'm talking about the engine mounts. All right. These 2 cylinders right here where my mouse cursor's at. And I get a pin right here. Okay. They're mounted to a cross member right above the steering rack. And then we have these triangle adapters that go to the bell housing of the transmission. Nothing's holding the engine once you take the transmission out. Okay. Because you got to unbolt these brackets. And unbolting these brackets is a pain in the butt. If you don't have some sneaky wrenches, you're going to spend most of your time working on these bolts. It sucks. And I'll show you some more why. Especially this one right here on the side. Okay. 8-inch long bolts and they go straight in to the frame of the vehicle. It sucks. Okay. This is a picture of me pulling out a transmission. We're going to look at this left photo right here. You have to temporarily disconnect the universal joint on the steering rack. Now, you don't have to take it out completely. You don't have to take the universal joint out completely. Leave it on the steering column. All right. Just unbolt it from the steering rack. This is keyed. Thank you, Lord. It's keyed. All right. That's what this little plastic wedge is right here. So if you dick that up, you're screwed. That prevents you from doing alignment. So there's enough extra shaft length on the steering column where you can shove the universal joint up and push it out of the way and just let it stay. Then you can work this one bolt out here in the rear. Come over here to this upper right hand corner. We got our triangle bracket right here. And there's that bolt that deadens right into the frame. That bolt rides the whole length of this adapter, and when it hits the frame, it's completely flush with the inside of this adapter. That's as far as it's designed to come out. The only way you can get this bolt out completely is either to drill a hole in the frame or you remove the bracket with the bolt. So you got three bolts. The top one's easy, the bottom one's kind of easy, and the side one's a pain in the son of a gun. All right, because you'll note, let me get rid of these marks so you can see. When you're wrenching that thing out, you're going to run out of room for your socket and wrench. You might only get this thing out about 2 or 3 millimeters before you can't get your socket and wrench out. So, what do? Well, the mountain wrenches are your best friend. Okay. And make sure you get the mountain wrenches that have the little flappy paddle on them so you can put it back in the forward gear. All right. Because if you got the ones that only have where you got to flip them around to get them to go the other way, you're screwed. You're cutting your wrench off or you're cutting that bolt off. One of the two. So, what do I do to combat this as a service technician who does this regularly? You get two. You get two mountain wrenches with flippy paddles on them. All right. So when you walk them out, you just abandon your wrench in place. That's how I do it. Hey, we got CP in the house, dude. CP, thank you for the $2. Thank you so much. And then bottom right hand corner, we're super zoomed in. There it is. It's crashed against the frame. It's actually all the way out of the transmission. You're safe. All right, so you took your torque converter off. You want to check the seals on your input shaft right here. You got two of them. So when you talk to the parts store at the parts department, make sure they know they're giving you two and they're different sizes. And they're not O-rings, they're actually plastic. They're plastic locking clips, but they still make a seal. All right, because they want to flex out a little bit, but they have a lock right here where they meet up and it's got a little bit of slop in it. So sometimes when you pull your torque converter off, you can nick that thing. And sometimes when putting it on, you can nick that thing. So as cheap as they are at $5 a piece, get new ones on there because they might be worn out from just the torque converter riding on them. And if you ever had any kind of torque converter lockup problems with these transmissions and you don't have a check engine light, it might be this seal right here. Okay. Or it might be the one back here. This bottom picture right here, we're looking at the side top of the transmission. I'm using a brake measuring tool. This is a 4 millimeter measuring stick. That is how far your torque converter has to go into the bell housing. All right. 4 millimeters. The actual spec is kind of like over here on the right, but everyone I've measured with this, and I do measure them before I put them in because I don't want to be that person who breaks an oil pump. But that's your cheat right there. Get one of these little measuring sticks. They're on Amazon. They're like $10 for a set. All right, so we got our in now we're getting into what's going on inside this transmission. That first part there that was talking about services because that's what most people are most interested in is how do I change my torque converter? How do I change my valve body? How do I change my fluids? So we got that mess out of the way. Now we're going to get into talking about what's in the guts of these things. All right. How's the power flow work? How do these solenoids work? How am I going to look at my PID data? All right. So you got some obvious things on here that you can see. We can see the torque converter. Okay. The torque converter, the input comes in. We go through a primary reduction gear. Then we go to our first pulley. All right. We'll talk about the pulleys and how they make gears. Then it's got a chain, sends power down to our second pulley. All right. Make sure I didn't miss anything out of my notes because I'm talking ahead of myself on the next slide. La di 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 da. Yes, yes, yes. Okay. Yeah. We're not going to bore you with that. This is our power flow chart. All right. So if you got a way to take a screenshot, you'll want to take this screenshot if you got a Gen 1 TR 580. So our power comes in through the torque converter. It goes through our reduction gear set. And we have this here so that way we can bring up the pulleys. All right. Because otherwise, this transmission would have to ride lower to the ground and it would risk getting hit. So that's why we have this gear set here to set it up for the primary pulley. Our chain connects to the secondary pulley. Then it goes through another gear set so that way we can send power out the rear shaft here to the rear gears. But we have another change up gear set here to allow power to go to the front wheels. That's your all-wheel drive. Now keep in mind that back here in our tail housing, that was our multi-plate clutch pack. All right. So if your valve body solenoid for the all-wheel drive system is malfunctioning and you want to determine if it's a solenoid problem or a clutch pack problem, you can use your scan tool. If you got a bidirectional support, you can command that thing to shut up and you can make your car run in front wheel drive mode. All right. It's under special functions and it's called front wheel drive mode. And oil pressure will be dropped for this multi clutch pack. And the power to the front is hard linked with gears. So the car is designed to fail in front wheel drive. The differentials in the Subaru. This is not a differential class, but just for G Whiz, we do not have limited slips on these variant types of Subarus that we're specifically talking about for the CVT class. They're open differentials. All right. Well, why don't we have limited slips? I thought they were better. Well, we have VDC. Okay, we have a hydraulic control unit that can talk to the calipers on the wheels, all right? And that hydraulic control unit, controlled by its own independent computer, it can pulsate those calipers in microseconds and it can lock up an axle, which can shoot power to the other side. So that's how they reduced cost on our all-wheel drive system by not using a limited slip, which could have clutch packs that eventually fail. We have an open differential, which lasts a lot longer if you change the fluid, and we just pump the brakes with a computer. This is another graphic just showing you the power flow. All the gears here are just highlighted in red. You can see back here in the tail housing, we are hard linked with a gear with power to the front. The torque converter does have a piston in it and it does have springs in it, and the springs are just there for noise dampening. Just some cool specs here about its stall speeds. 2400 is about the average that I see. The highest stall speed I saw was 2900. We'll get into how to do a stall speed test. We're gonna backtrack and talk about our oil pump here and how our oil pump is actually linked up. So the torque converter, do I got it on the next slide? Yes. Okay. Right here, your torque converter keys into here, and then you have a chain. Now that chain has a black mark on it only for the fact that that is the chain that linked the chain together. It's not a timing mark. You just slap the chain on. Over here, we have a tiny, tiny little gear. So big gear turned to little gear. There's your ratio. Do I got a ratio what that is in the notes? No, I don't have that ratio. But that pump is spinning stupid fast. So your torque converter is driving your oil pump. So if you don't install your torque converter correctly, you don't engage your oil pump correctly. I very I have never seen any of these components fail at all. I've never seen a failed oil pump. I've only seen people screw them up. All right, this is a picture of how the pump keys into your torque converter there. Here's the pulleys. All right. This is the fun stuff here. So you got a primary, you got a secondary pulley. I'll label them right here for you. The one on the top is primary, the one on the bottom is secondary. Now, there's one major difference that's important to note between the primary and the secondary pulley. The secondary pulley, represented by these black dots because it's a sideways cutaway right here, it's actually a return spring. Okay. That secondary pulley wants to close all the time by mechanical force, not hydraulic force. So it's really cool how we make the infinite gear system work. What we do is with the using the TCM through the control valve body, we're using the primary control solenoid. We're using the primary solenoid, which is huge. It's like the size of a Snicker bar. Okay, that's our primary pressure. It comes in here and it fills the void up on the primary side. All right. And when this, oh, sorry, I got it backwards. Blah, blah, blah. Primary pressure, here we go. Boom, coming in on green, fills up this void right here. Now, when it fills up this void, that pulley starts closing its gap. All right. That chain is designed to be manipulated a little bit. But how do we make the other pulley work? Well, we shut down the lubrication circuit on the secondary pulley, okay? So there's no pressure in there, but we got a return spring. But this primary can squeeze that chain. I'm sorry, that primary pulley can be squeezed together, which then pushes the chain on the outside of the drum. And then the chain is pulling and spreading the secondary pulley apart. That is it in a nutshell. And when we accomplish that, we now have the chain on the outside here creating a big gear. And this chain now is riding on the inside shaft down here. And we got a small gear. So you got a big gear turning a little gear, low power. Let's erase those marks and clear. Okay. We can reverse that when we want to create our overdrive. Okay. We need to get the chain on the shaft of the primary pulley, and we need to increase the size of the secondary pulley. So we just shut down the primary circuit on the main pulley, the primary pulley. It has a lubrication pump in there to keep everything happy, but it's not building up pressure. And because the secondary over here is now filling up with secondary line pressure, The primary pulley can be pulled apart by the chain because we're down here on the secondary pulley making a big gear. And now we got a small gear on top. And that is happening uh, in milliseconds. And it's going to throttle back and forth between primary pressure and secondary pressure, and primary pressure and secondary pressure. It does that in a pulse modulation control circuit, all controlled by the TCM to just find that gear that it wants. And it's just going to keep making big and small and big and small and big and small. It's never really going to stick in a fixed ratio unless you're in the manual mode of operation. Then you have those 6 pre-programmed gear ratios that it's going to stick into. All right, so here's examples of our primary pulley right here. The chain's riding on the shaft. We're swole down here on the secondary. The chain's riding on the outside of the drum, and vice versa. So we got our overdrive and we got our low gear. That's it, guys. That's how we make gears in a CVT. Now, where's the wear come in? Well, that chain does have to be lubricated, and that chain is clashing against a metal surface. All right. It's got metal and metal contact. This is why I harp so hard on changing your fluid and doing it frequently. You're not going to hurt the transmission by changing your fluid out every 30,000 miles. It it needs that film of lubrication. And if that fluid is broken down to where it can't lubricate properly anymore, then that's when that chain gets hot because of friction and it snaps, it breaks, or it causes wear to the pulleys here, and those just wear out because they got pistons inside of them, and you can wear out the pistons with rotten oil. Think of this lubrication like engine oil. You don't run 10,000 miles on engine oil, do you? Your pistons are going to get angry because there's a very fine tolerance between your pistons and your cylinder walls. More pretty pictures here. Going into the strategies here. We'll skip over that. This is some pretty advanced stuff. Okay, we're talking about our Ford. Okay, yes. All right. So, how do we get forward and reverse out of here? Well, we got a forward and reverse clutch. It has a single planetary gear setup in here. And by changing the power flow through the forward and reverse clutch when you're in drive, you make the clutch go backwards. It holds our planetary gear set in a fashion to where we're rotating the shaft clockwise, and then we can change our setup so we go the reverse direction. Labeled here the solenoids for you. Now the parts catalog through Subaru, we don't have individual solenoids. So if you blow out a solenoid, we're going to sell you a whole new valve body. And the reason why we're going to do that is because we tell you if you wore one out, you eventually wore out another one. Now, can you get on eBay and Alibaba and find rebuild kits? Yeah. Have they worked? Yeah. But as people cause damage to the valve body replacing this? Yes. Yes, they have. They break the wiring harness. Okay, so we do put sensors to monitor what's going on in the transmission. Okay, we got our secondary speed sensor, front wheel speed sensor, primary speed sensor, and we got some hydraulic speed sensor going right there. Now, your primary speed sensor is for your primary pulley, and your secondary is for your secondary pulley. Yay! So easy to figure out. Now we're into my favorite version of the CVT here. It's the TR690. We launched this sucker out in 2015. It comes out only on the six cylinder at that time. It didn't hit the four cylinder until the turbo came back. When the Outback XT came back and the Legacy XT came back, it got this sucker, the TR690. The TR690 is an overbuilt version of the TR580. All right. We beefed it up with better components, heavier components, because it was getting a bigger engine that could put down some torque. I don't have problems with this thing, minus a valve body replacement here and there. Never had a torque converter problem. Very rarely have a valve body problem. And if somebody did have a center diff multi clutch pack problem, the car's got a lot of miles on it and it was never taken care of. I cross my fingers. I call this transmission pretty bulletproof with the six cylinder. It was very well built for the engine it was married to. We'll talk about how the TR690 is having some problems with the Ascent because the Ascent has a completely different engine setup and it's got a snappier torque converter to throw down power because the Ascent one is stupid heavy, and two, they put a tow package on the Ascent. No Subaru in its life has been told it can pull anything more than 1,500 pounds. And if anybody knows anything about trailers, your trailer can eat up all that weight stupid quick. All right. So if you're like, yay, 1,500 pounds, my little boat I just bought from Craigslist, that thing only weighs 600 pounds, so I can pull a boat. No, you can't because your big ass trailer is probably 1,500 pounds all by itself. The trailer eats up the weight. The trailer hitches on these Subarus, they're really meant for bike rack accessories and whatnots. So that was a big complaint. People wanted to pull things. So they made a version of the TR690 that we'll get to at the end for the Ascent that has a tow package to pull 5,000 damn pounds. The 2009 Legacy, 3,000 pounds, my man? No way. No way. That thing's governed down to like 12, 1,300 if you got a six cylinder. That's a light duty pull. Now you, oh, unless you're talking about curb weight. Are you talking about curb weight? All right. So you're going to notice that the TR690 is very identical in everything to the Gen 1 TR580. That's why I don't cover it that much with the mechanics. 2,700. Let me check my stuff out. 2009 Outback tow rating. Dang. That's an '09. Now, if you get into the six cylinder ranges, you got to be careful between your four cylinder, your six cylinders, and you got to read into the specifics. But also keep in mind to read your owner's manual too. That's a really big number, but that's also taken into account all the human bodies in the vehicle and all their cargo. It's a classic mistake in the Subaru realm. They get excited, they did a Google, they saw what they can pull, and they're like, "Yeah, man, let's load up the pop-up camper. That thing's only 2,500 pounds. All right, well, you put a driver in there, he's 200 pounds. You got a passenger, another 200 pounds. Then you got your family, and then you got all their luggage, and then You max that out. I seen people squat the hell out of some Subarus because they want to pull a pop-up camper and they took their 2.5 kids and their dog and all their playthings for the weekend and they burnt their transmission up. I had one guy who got in an argument with me about it. Um, because he says, "I don't understand." I says, "I made it to the campground and it was 400 miles away. How come I only had a problem coming back?" Well, he didn't take elevation into account. The way to his campsite was an elevation drop of 600 feet. So he had an elevation climb of 600 feet all the way back up, and that transmission just shut down on him. Rather force reforms at 227 Fahrenheit and beyond ages the shellac. Yeah, it does. Yeah, these transmissions, they got a sweet spot for heat. But guys, I'm taking notes on what you're telling me too. This is good information to share for future classes. But yeah, it's finding the threshold of running those transmissions hot. You're taking days off its life. Okay, here's our side view graphic of your power flow there. Everything's the same as the previous Gen 1 TR580. Super simple. It's just beefed up. But it does have its own unique high torque fluid. All right. It resists overheating better. It uh, helps out with the components better. About the biggest upgrade that comes to mentioning here is the planetary setup. We went with a double pinion setup instead of a single planet there. That helps out with the torquiness and with the the power to handle the power out of that six cylinder. Aluminum flattened trailer, yeah. It's guys, I got the little crappy little 4 by 4 foot Harbor Freight flatbed trailer, and I think by itself that's 500 pounds. But that's just like for doing like some light haul, like maybe I'll grab a washing machine or something like that. I just don't risk it. I know in my bones Subaru was not meant to pull things. That's it. It's a great car to get in the trails with, to load up the cabin with a bunch of people and luggage, but pulling things, I'll never sound confident in advertising it. I really won't. It's the death of us. I don't see CVTs having a tow package. It's stupid. Now, if they brought back a 5 EAT and beefed it up, then yeah, maybe. All right, so we're going to focus on our multi-plate transfer mechanism here, the MPT, as they call it, aka the center diff. All right, as I said before, it controls the torque split. We are 60% biased to the front. It is a pretty simple device. We are hard linked to the front wheels. We are soft linked, as I call it, to the rear wheels. This pressure that controls the slip and the lockup of this happens in a pulsating modulation of pressure to find that sweet spot from the all wheel drive control solenoid. Some other inputs that are taken into account to control this clutch pack right here. All right. So I told you the all wheel drive solenoid is commanding the pressure here, but the TCM is also taking monitors from your steering wheel angle, the yaw rate sensor, and your lateral acceleration sensor. All right. It's taking all that into consideration because cornering is important. You don't want to be flinging power to the rear wheels when you're cocked the steering wheel to the right. You want power in the front to pull you out of a turn. And then when you get straightened out, power to the rear. So if you're having a performance problem with your vehicle and you're not getting any codes, check out these other sensors and diagnose them. I've had some cars come in from body shops. Customer comes in and they say, "Man, so every time I take a turn, like it feels like somebody is kicking the rear end out of my vehicle." And I took it to another shop and they replaced this thing and it's still happening. Joe, I can't figure out what's going on. So I drive the car, I do a figure eight test, okay? And yeah, I'm like, yeah, this thing's bucking in the rear. Sounds like this thing is slamming with pressure. It doesn't know what to do. Come to find out, they had a glitchy wheel speed sensor. That's all it was. TCM didn't know what was going on because it was like, yeah, this guy's acting dumb. But it had enough software in it to try and compensate and figure something out. It was just enough of an idiom happening that it didn't set a code. Yeah, we finally put some transcoolers on the gins too. And if you get an aftermarket transcooler, I won't shame you for it. It's actually a really smart decision. Just make sure you get the extra fluid to compensate for it. And don't get a cheap one. Oh, no, God, no, don't get a cheap one. The cheap ones, they blow apart. I think the cheapest one I found that I helped somebody put in cost them about 1,500 bucks. Hardline fittings all the way. The cheap ones use hose fittings. I won't trust that stuff. Do the rear angle Okay, let me do the rear arm angle sensors affect this? The rear arm angle sensors. Okay, so on the rear what is okay, so what I suspect you're talking about there, Ninja, is the in the back of the vehicles, some of the Subarus have what looks like a third end link that's connected to the chassis and the lower control arm in the rear, and that determines how much weight is in the rear, and it also determines if the vehicle is squatting under acceleration. So yes, that is taken into account. Um, when we finally got headlights that could look left and right a little bit, they also tilt up and down. So if you got some heavy weight in the rear end, the lights point down. I hope that was the answer that you wanted. Otherwise, send me a picture and I'll follow up with you offline. All right. So, center diff, it's all software driven. That's it in a nutshell. I talked about that in the earlier slide. This is your hydraulic control unit that's in the engine bay and unique to the TR580. I'm sorry, unique to the TR690. They put the TCM right next to it because they like each other. No, it's not it. That's just a joke. That's a bad joke. They couldn't really give two shits about each other. It's just that some engineer said if we start putting computers in the engine bay, we can save a lot of money on wiring harnesses. Or maybe another engineer said, "Hey, these guys are going to be troubleshooting this stuff a lot. Maybe we should make the computers easier to get to." One of the two. I should have put this slide further up when we talked about this already. So here's your shift points here. If you were using the flappy paddle shifters. Oh, no, no, no. I could have used this, but no. This Okay, so the TR-690 came out as part of the Generation 2 package. One of the big software updates that was introduced into the Generation 2s, and this is in the 580 also, was these fake shift points. Okay, so if you remember the first version of CVTs that came out, the engines would just rev all day. People were scared by that. They thought their engines were going to blow up. There was no problem with it. People just didn't like it. And they also didn't like the noise that came with it. To appease the mass and give them their automatic transmission shift feeling because they wanted to feel the gears. We programmed in fake shift points. Awesome. All right. So where are we at? We're coming up on 2 hours. This is a great spot to continue next week. I'm losing my voice a little bit. I want to thank y'all for hanging out. When we get into it next Saturday, we're going to drill in to how the power flow is going through your valve body when circuits are activated. Okay. We're going to be looking at some PID data. And if you start graphing this stuff out on your own, what you're going to see on your scan tool and you graph it out. Everyone here, man, you guys have been a fantastic audience. I'm going to hang out for another 10 minutes. If anybody wants to chime in for a question, go back and review some other information or has any feedback on what's going on. Because it's going on 10:30 Central Standard Time. And I don't want to keep you all up all night, but you have just been a fantastic audience. Best group ever. You're welcome, sir. The Thinker. I hope this series is a big success. I honestly want to build more modules like this for the very near future. I want to do one starting all the way back to the EJ engines, get into the FAFB engines, do an STI class for you. Oh, dude, you'll have so much fun. I do recommend that you read that new technician reference booklet that they released about a year or two ago that really did answer a lot of problems for people because the first two training books that they came out with about 10 years ago, they suck. They're just not helpful. They're just full of engineer talk, expecting you to kind of know what they're talking about. But they really cleared things up and the new couple of books that they came out, especially the book that was just designated for diagnostics. But the only way that you can really, really get this stuff down is to just read the book yourself. Say the words out loud, go through the laptop, okay? Get your Subaru laptop and go drive a car and walk the steps, okay? We're going to we're going to go through these circuits in the next class and apply that to what you're looking at on the scan tools. So many people get intimidated by this information and they just want to condemn. They're like, the transmission's at fault. Man, do you know how many problems I fixed because a car had a misfire? People forget the simple thing that a transmission does. The transmission's a torque multiplier. So if you got so the transmission's a garbage in, garbage out device. If you got garbage power coming in with a misfire, it's going to amplify that 1,000%. So it's a really common mistake when a customer comes in with a drivability concern. They're like, hey, my car falls on its face. It's got no power. It's these crappy CVTs. I want a new CVT. No. Well, let me see what your engine's doing. And I'll put together an engine class for you. And I'll talk about the telltale details of how some simple things of not doing your tune up, having a clogged throttle body, having a broken EGR can cause these vehicles not to move correctly until you get so much engine load on it, then the transmission picks up. And again, I talk about software. You have to know what the software is doing because this software is so good that you can have an engine falling on its face and it's still trying to work. It's not like the old days where if something broke, nothing worked. Now these cars move with broken parts. It's pretty cool because it's software. So good luck to you on that class. Pay attention, ask questions, because you're going to be the one helping people. I want you to do good out there. If you got questions, man, email me. Go to my channel page. My email's up there. You know what? In fact, I'm being a moron right now. Boom. There's the email. Okay. If you got questions, send me an email. And if you're data logging something, you can send me a file or take pictures. Okay. I love helping the community. It actually helps me grow better as a mechanic and a technician. Y'all been wonderful. We're going to do my sign off. Thank you. You're a great audience. Have a good night.